In your last class, I have discussed up to shear fold, how they are formed and how they look like. In today's class, I'll be discussing I'll again talk about the fold classification on the basis of nature of the hinge line. So on the basis of nature of the hinge line, how the hinge line is it rectilinear or is it curved or is it in a conical shape? Depending on that, it can be classified into two types. So one could be the cylindrical type, another could be the non-cylindrical type. For the cylindrical type, what happened? A cylindrical fold has a rectilinear hinge line. What does this mean? So this is a cylindrical. So if you draw the hinge line here, so that will be the hinge line. That is your hinge line, and that hinge line is almost straight line, or it's a straight line. Okay, and if this hinge line moved in one direction like this, it will make a cylindrical shape. You know that, right? The concept of being a cylindrical shape, a cylindrical shape. So a fold which can be generated by moving a line parallel to itself is called a cylindrical fold. For the non-cylindrical fold, when a fold which cannot be generated by moving a line, then it's called a non-cylindrical fold. What type of folds are non-cylindrical fold? First one is the conical shaped fold, or it could be the curved fold. Okay, the example of non-cylindrical fold. So here the hinge line is curved, you can see. So it's an example of, you can say it's a doubly plunging fold. So it's a doubly plunging fold. Okay, so this type of fold are non-cylindrical fold. What is a conical fold? One part of the fold or one side of the fold, it will look like a conical shape. It's giving you an idea of a conical shape. It's called a conical fold. This one. So a type of non-cylindrical fold whose shape approximates a part of a cone, then it's called a conical fold. It's as simple as it looks like. Now, based on the curvature of the axial surface, we can also classify the fold in several types. First one is the plane fold. So what about the fold we are discussing, the classic old regular fold from the day one? That is our plane fold. This one is our plane fold. Why? Because the axial surface in this case, what is the axial surface? Are planar. So on the basis of the curvature of the axial surface, see, we can classify it. So this is a planar shaped axial surface. That's why it's called plane fold. So it can be, these are generally described as plane cylindrical fold or plane non-cylindrical fold. This is also a planar fold. So it's a plane cylindrical fold. Plane cylindrical fold. Anticline or syncline? Is it a anticline fold or syncline fold? It's an anticline fold, right? And this is also a planar fold, but this fold is a cone fold, cone shaped. Okay, so it's a cone shaped fold. So this fold is also planar. Why planar? Because the axial plane is planar. So axial plane is a plane, not curved. So it's a planar non-cylindrical fold. Got it? Now if there is another type of fold is there, that's the cylindrical fold, forms an oval outcrop, may not always form an eye-shaped outcrop. So this type of fold is also called a eyed fold, and this type of fold is called the sheath fold. Or the type of non-cylindrical fold which hinge line is strongly curved like a hairpin bend, just like the hairpin bend. Okay, it's a strongly curved, that's why it's called sheath fold. Now tell me, this one and this fold is your eyed fold. Now tell me, what type of fold are these? Is it planar or non-planar? By seeing the axial surface, what do you think these folds are? Class, is it planar or non-planar? Which one? Is it planar? Because you are seeing the axial surface. Okay, axial surface is not curved. So this type of fold is called planar fold. So this is an example, or this is a schematic diagram of the eyed fold. Planar eyed fold, and this is the schematic diagram of planar sheath fold. Okay. For the non-plane fold, when the axial plane is curved, if you have this kind of folded structure and this axial plane is curved, that's called the non-plane fold. See the curvature you can see here. It's very simple. And again it can be classified into two types. One is a non-plane cylindrical fold, another one is non-plane non-cylindrical fold. So this one is the non-plane cylindrical fold. Why non-plane? Because axial plane is not planar. And why cylindrical? Because the shape you are if you take a line and you move the line in this direction, you can move it, right? So it will form a kind of cylindrical shape. So it's a non-plane cylindrical fold. It's a non-plane non-cylindrical fold. The axial plane is curved, and again it's a not a cylindrical structure. Now based on the shape of the hinge, these things are very important. So you might want to put a star on that. Round hinge or concentric fold. Round hinge fold are those, a fold with a broad hinge zone compared to the limb is called round hinge structure. So if I draw a round hinge fold, that will look like this. So this type of structure will be generally called as a round hinge structure. Okay. So I might, yes. So concentric fold or the round hinge fold is this. Another special type of fold also existed, that's called the zigzag fold. So it's a fold with a straight limbs and with sharp hinges like this, like in a zigzag style. And there is a photograph. Yes. So here you can see the zigzag pattern is always visible. So the zigzag pattern is visible. Several strata are there. Several foliation structure is you can see. So this type of fold is a special type of fold, and this zigzag fold is called chevron fold. So what's the basic idea of the chevron fold? Is a fold with straight limbs with sharp hinges. That's the basic criteria to describe a fold as a zigzag fold. Okay. Now another important one is your arrowhead. So a fold with a sharp hinges and distinctly, give me a minute. So if a fold with a sharp hinge and with distinct curved limbs you can see, then it's a arrowhead fold. So it's look like a arrowhead. If you draw an arrow here, so this thing is looking like a arrowhead. So this fold is your arrowhead fold. There is another type of fold is there, that's called the cascade fold. It's a train of fold with sharp hinges, one set of closures and with rounded. So your hinge will be rounded. Okay, and this will be thicker comparing to the limbs. And another thing will happen, the fold with a sharp hinge on one set of closure and with rounded hinge on the opposite directed closures. So at this point, if you consider the syncline point, you will have the sharp one. If you consider the anticline part, you will have the rounded. So there are two type of hinges you can see here. Okay, and this point is thicker and this point is thinner. So that's the basic difference between the cascade fold and the arrowhead fold. These things are very important. You just note down the name like cascade fold. So based on the number of hinges, it can classify the fold with single hinge between 2 points of inflection. That's called the single hinge fold. A double hinge fold is a sharp hinge fold where fold with a sharp hinges. A fold with a single hinge between 2 points of inflection, that's called single hinge fold like this. The fold we used to draw, that's the single hinge fold. So it's a single hinged anticline. So conjugate fold will look like this. So it's a doubly hinged fold. Okay. So see here, a double hinge fold with sharp hinges. You can see that's the double conjugate fold, and this is the photograph of a conjugate fold. And this type of fold is called box fold, and it's very important. It's also is also easily available in the nature. So a double hinge fold with sharp hinges is called box fold. So this is an example of a box fold. See, if I could plot, so your hinge are this, and this is the hinges. Okay, so these hinges are very sharp. So it's called it's a double hinge 1, 2, and these hinges are very sharp. So it's called the box fold like this. So this is an example of a box fold. This is the conjugate fold. Based on the fold trend with reference to the, it could be longitudinal folds, it could be transverse folds. Just very simple. Now, the topic I really wanted to discuss, that is the special types of fold. First one is the fan folding. Just draw this diagram, draw this one, then I'm discussing. So what do you mean by fan folding? Okay. So if in any fold both the limbs are overturned, the fold is assumes the shape of a fan. Okay. फैन मीन्स इट नॉट योर घर का जो पंखा है वो नहीं है. फैंस मीन दिस टाइप ऑफ स्ट्रक्चर जनरली मेड बाय रिवर्स एंड इट्स कॉल्ड द फैन डेल्टा. You might have heard of it. So it's looking like a fan structure. Okay, and fan fold, when the folded structure is looking like this, both the limbs are overturned. Both the limbs are overturned. Okay, that type of fold is called fan folding. For the anticlinal fan fold, the two limbs dip towards each other. See, it's dipping towards each other. For the synclinal, it will be dipping away from each other. So what's the interlimb angle here? This side, if I take, this is the inflection point, this is the inflection point, and if you take the tangent, then it will not intersect in this direction in the conventional way. It will intersect in the opposite direction, and it will make an angle. So this type of interlimb angle is it's a negative interlimb angle is calling. So this side, if the intersection are happening in this side, on the closing side, then it will be called as a positive intersection angle. And if it's happening in the negative side, it's called in the opposite side, it's called the negative intersection angle, because this side में वो intersect नहीं कर रहा है. So a fan fold is one in which both limbs are overturned. Another type of special fold is there, that is called king band. These are the narrow band, usually few centimeter, 1 to 2 centimeter wide, and it could be few centimeter to few inches, or a few feet wide. Okay, and in which the beds assume a dip which is steeper or gentler than the adjacent bed. So in this folded, in this king plane, you will be seeing the bed assumes a dip which is steeper than the normal bed condition. So this type of fold is called the king bands. See, so if you see this kind of folding, that's called the king band. Geosyncline is also there. Literally it means the earth syncline, but it is geosyncline. Sometimes it's synonymously used as a basin. Basin means it's a large depression. It's a kind of bowl-like structure. Okay, so geosyncline is the literally earth syncline, but its larger depression is called geosyncline, and this geosyncline structure is generally filled up with sediments. Okay, so sedimentation will happen layer after layer due to the activity of water. Okay, so in which it many thousand or 10 of thousand of feet of sediments may accumulate. So it could be several thousand feet of accumulation of sediments, and it's a large structure, very much wide. Generally happen mainly you will find where the river works or sea sediment depositions are happening. So this type of structure is called the geosyncline. Now, how can you classify a fold? How can you identify a fold in the field? See, fold structure I have already discussed. It could be the wavelength. I am talking about the wavelength. Could be, let's say, it's a 10 kilometer wide. So it's a huge structure, and some portion will be some portion of that you will be seeing as an outcrop. So how can you classify, how can you understand it's a fold, which type of fold is there? So first So we are talking about recognition of folds in field. Okay, so first one you can do that aerial photograph. You take a high resolution picture by via drone or satellite, okay, and from there you will be seeing the outcrops, or you will be identifying the outcrops, and there from that outcrops you can understand if this is a fold. Or suppose there is this fold which is consisted of several set of crest and troughs like this. This is the second layer. I'm drawing a 2D figure. Okay, like this. So this is strata 1, okay, and this is strata 2. So this is strata 1 and bottom one is the strata 2. Okay. Now after erosion, the upper part got eroded. For some reason, the upper part got eroded, and you will be taking this straight line and क्या हो रहा है? Okay, so I'm taking a straight line here and the upper part got eroded. Suppose this portion will be removed, so remove this. Now if you do the structural mapping, so what you will see will be first, so say this is 1, this is, let's say this is 1, this is 2, this is again 1, this is 2, this is again this is 1 again, sorry, this is 2, then again 1. So what you will be seeing if you travel from this side to this side, if you do the structural mapping, first you will be seeing, take a drone shot 1, okay, this strata, then you will be seeing 2, second strata, then you will be seeing 1, then again you will be seeing 1, then again you will be seeing the 2, the second strata, then again you will be seeing 1. So you are seeing a repeating pattern, and by seeing this repeating pattern you can identify, okay, this is a fold structure is there. Or what you can do, and in case of plunging fold, what will happen? So plunging fold has a outcrop like a nose. If it's an anticline, it will look like a nose. And plunging fold, as a rule, give rise to the curved outcrops, the apex, which is called closure or nose. So when you'll be seeing this type of structure, is called you'll be saying that it's a plunging fold inside. Then drag fold, rock cleavage, cross bearing, these things are also you'll be seeing throughout that. So I'll provide you a study material on this. Read that. Okay, and then you will be done with the folding. So by stating this part, by stating the recognition of fold in field, I have completed the fold part. Now let's talk about joint. What do you understand by joint, and what do you mean by joint, and when I'll be saying it's a joint, not fault. See, let's talk about fracture. Before understanding fracture, let's consider a real life example. We have a glass block or glass piece, okay, and you give some lateral pressure, or you drop a hammer here, small, such that the hammer make a, or let consider a real life example like your cricket ball hit someone car window, okay, someone car's window has been hit by your cricket ball, and कैसे वो फ्रैक्चर डेवलप होता है, ग्लास टूट नहीं जाता है, the glass was not shattered. If the glass was not shattered, then it will create some fracture on the windshield. Same thing happen if you give a rock body or rock structure under some lateral pressure or anything, and it's very common in each and every rock body. You will find this fracture. So fracture is very common. Okay, so then there you will be seeing some kind of fracture lines. Okay, and if there is movement between, so this is the fracture line, this side of the block and this side block of the block, if they don't have the relative motion. What do you mean by relative motion? Suppose this is the block of rock, okay, and this is how a fracture developed due to some lateral pressure or due to some earthquake activity. Okay, so in general earthquake activity, fault planes are developed. Fault plane or fracture in the rock is developed. Okay, so suppose this fracture is developed, and now this is block A, let's say this is block B. If there is no relative movement between block A and block B, then you will be seeing it's called joint. If there is no relative movement between A and B, it's called joint. If there is a relative movement between A and B, like okay, so this is block A, this is block B. This point on B was initially at this point. Okay, so there is a displacement, and then it's called fault. Let's make a 3D diagram. Okay, if this block slided on this plane, it's called the fault plane. Okay, so on this fault plane, if this B block slided down, then you will have a structure called fault. So when the rock break in response to stress, the resulting break is called fracture. So you are giving some stress, and under that stress the rocks break, it's called fracture. If the rock on one side of the break shift relative to the rock on the other side, then it's called fault, like this. If there is a relative motion, this block B is shifted with respect to A, then it's called fault. That will be discussed in your next class. And if there is no movement on one side relative to the other, then it's called joint. Okay, so joint are basically crack or fracture that divided the rock into several parts, several blocks like this, like A and B I have considered. Okay. Now joints with a common orientation make a joint set. So joints generally don't appear randomly most of the cases. You will find some kind of fracture lines going through this, or going through this, or going to parallel to the strike, or going parallel to the dip. So this is called a joint set. Okay, and this type of joint or joint fracture is also available in all type of rocks, either it's igneous, sedimentary or metamorphic. So every rock you will find joint most likely, and joints are planes of separation. If I define joints, which are the planes of separation on which no or undetectable shear displacement has been taken place. So let me show a photograph of joint. So this is a photograph of joint sets. See, they are fractured following a straight line pattern, but there is no relative movement between the blocks. That's observable. That is called your, so this is the joint plane. Now there is another thing you should know, that's called the aperture. That's called aperture. So what do you mean by aperture? Aperture is the space between its two walls. There is a space between two walls. Sometimes this space is filled up with the white material you can see. This could be some chemical precipitation. Okay, or this could be some another mineral depositing here for some reason, of for some placer deposit could be there, or some cementation may be there. So the space between these two layers, this block and this block, the small space, is called aperture. So a joint with a large aperture, so if the gap is larger like this, then it's called fissure. Okay, and that the mechanical layer thickness of the deforming rock controls the joint growth. So if the In coring, the large rest block size depends on the joint frequency. Abundant fractures are desirable for coring crushed rock and gravels. This is for the mining students. Now let's discuss about the joints classification. It can be classified depending on several parameters. First one is the mode of the formation. Second one will be the based on the attitude. Attitude means strike and dip. When I talk about the attitude of a bed, that means I'm talking about the dip and strike of the bed. So it can be classified into tension joint. So what are the tension joints? So tension joints are formed as a result of tension, as obvious. I'll discuss in details how columnar joints are developed. And these relatively open and have rough and irregular surface are called the tension joints. So the example is columnar joint. Very is abundant in USA and Canada. This size you will see this type of joints. It's a hexagonal shaped block are joined one another by a weak plane, and this type of joints are generally called as a columnar joint. What is a shear joint? Formed due to the compressional forces. So if you are giving tension here, so generally if you are giving lateral pressure, then you getting the tensional joint. If you are giving this type of lateral pressure, then you will maybe having this shear joint due to the compressional forces. Tensional joint generally developed when you are applying tensional stress. When you are applying tensional or stress, then you will have the tensional joint, which is a columnar joint. Example, for shear joint you will be using the compressive forces like this. This is the compressive forces. This compressive forces you are giving, and this type of shear joint you will be seeing here. The example of shear joint is conjugate joint. Again I will discuss what is the conjugate joint, like this. Now based on the attitude, it can be classified into three types. It's very simple. The strike joint, when the joints are parallel to the strike, these are the strike joint. Okay. When it's parallel to the dip, this is the dip joint. When it's neither parallel to strike nor parallel to dip, then it's a oblique joint. So it's called a oblique joint. Okay. So oblique joint or conjugate shear joint. Now based on the appearance, I said it will be okay. Now based on the appearance, it can also be classified as bedding joints or master joint. When the joints are oriented, these definitions are very simple. Just read it once. When it's parallel to the bedding planes, it's called the bedding joints. Okay, if there is a joint like this oriented in the bedding plane direction, that's called the bedding joints. What are the master joints? Strongly developed and extended long distance are called the master joints. So for the master joints, you will be seeing the joints for a very long range of very extended region. That's called the master joint. Primary joints are generally in igneous rock. Joints are formed during cooling and contraction of magma. Most famous one is the mural joint, when the set of joints are mutually orthogonal to each other, mutually perpendicular to each other. So they are making right angle. This angle is 90 degree. They are making this joint and this joint. So these type of joints are called your mural joints. Generally you will find this type of joint very common in granite. I told you that is for the igneous rock. Okay. Shear joints are the kind of again that onion example. Onion exfoliation, you know the structure of onion is called exfoliation, kind of that type of structure. So you will be layer after layer like this, one layer, second layer, here it's a flaky structure. You can see thin bed layers you can see here. So sheeting is a tensional due to the release loading during erosion, and exfoliation joints, which make the rock appear to be flaking off in sheet, occur when a body of rock expands in response to reduced pressure, such as when the overlying rocks have been removed by erosion. So this type of joint is called the shear joint. Now let's come to the very famous columnar joint. So like mud crack, columnar joints form the volume contraction. You know, I have shown you the picture of mud cracks, or you might have seen in your neighborhood that mud cracks are generally developed how? Volume contraction. How? Rapid cooling. So in this case, columnar joints are also developed due to the rapid cooling. So basalt generally solidifies at 1000 degrees centigrade, and it solidifies during the lava flow. Okay, so the resulting tensional force act primarily in the horizontal plane and equal in all directions with this plane. That's the important point. So what the tensional forces acting? So the resulting tensional forces act primarily in horizontal plane. First point. And second point, it's equal. That's why, as it's equal in all direction, that's why you are getting a hexagonal shape like this. This hexagonal shape you are getting only the forces, tensional forces are acting equal when the lava is undergoing to the volume contraction due to the rapid cooling. So the rupture eventually takes place, and if the rupture takes place, the three vertical fracture will be developed, making an angle of 120 degree with each other, and it will be radiate out from the center, or from the numerous center. So there will be hexagonal shape each time due to the tensional stress. This type of joints are called the columnar joint, and this is very important. Write this down, the name. Okay, so sometimes you will see on the folded structure it's very common to see strike the joint or longitudinal joint or diagonal joint or oblique joint. You can see also the cross joint. So it's very common to observe joints on a folded structure.